Good afternoon, and thank you so much for joining us for our webinar today. Today we're going to dive into a new area of Wi-Fi. We've talked in several recent webinars about various Wi-Fi technologies, from designs, large facilities, those types of things. But today we're going to kind of hone in on a piece of it, and that'll be on the security. So security is often kind of one of the forgotten things about Wi-Fi projects, because more interested in making sure we're getting coverage in those kinds of things. But in this case, we'll dive into the whole security piece. So I'm joined today by Alex Wilson, wireless engineer, and does our various work on wireless networks. So he'll be presenting today. Taking a quick look at the agenda. So after a few introductory remarks, then Alex will be diving in, talking about kind of what is the state of wireless. Let's take a look at Wi-Fi 6, Wi-Fi 7. How do we kind of secure those? Look at some of the history of wireless security, so you kind of have some context. And then we'll dive deep into the wireless security options, and also take a look at, well, how do you find the gaps in your wireless security that you know what you're fixing? And then at the end, we'll do some Q&A, and I'll talk about that in just a moment. Hopefully you have your pizza in front of you and you're enjoying that. If you do not have your pizza yet and you asked for one, just note Julie Dellinger's email address on the screen. Give them a few minutes. They may be trying to find your office or your home office if you're there, but also check if you are at your office to check and make sure they're not out in the lobby, behind, on the other side of a locked door, or wherever food seems to disappear in your office. And if not, just reach out to Julie. During the webinar today, the audio is in presentation mode, so you can hear Alex and I, but unfortunately we can't hear you. But we keep it muted so that any background noise where participants may be doesn't come through to the whole group. But you can reach me throughout through the chat tab or through the questions tab, and I'll be monitoring those throughout the session today. In the questions tab, if you put any questions as they come up, we'll do the Q&A at the end. And I'll read out those questions for Alex. He'll be able to answer them. It also has the other advantage, which is if we can't get to all the questions, we can still then email responses to you afterwards, because we want to make sure this is a good educational experience for each of you. This presentation will be, the PowerPoint of it will be available as a PDF that'll be emailed to you today, along with a link to the recording of this session, so you'll have that. And then finally, there is an evaluation that comes afterwards, and we try to make it a little bit more fun. The first way we make it fun is it doesn't take much time. It takes literally one minute to 2 minutes if you wax eloquent there. But we do try to, and the second way we make it fun is to try to do a drawing for a couple of the completed ones for either a $50 Amazon gift card or towards your favorite restaurant. You let us know which that restaurant is, and we'll pull those out of the completed evaluations. We do have some new folks joining us today, so just a little bit about System Source for a minute or so. So we've been around since 1981. There's about 75 of us here at System Source, and we work with IT professionals and senior leadership from kind of South Central Pennsylvania all through Maryland down into the DC area. And a lot of folks first come to us when they need to acquire technology. One area that they may be looking for, obviously, would be in wireless technology for implementing Wi-Fi, security, all the WAPs and switches, all the types of things that go for that. Also in user computing, but most of our work is done in the data center, whether that's going to be on traditional on-prem technologies, or if that's going to be in the cloud. Azure, Microsoft Azure is the primary place. Also Amazon Web Services, as well as other places that systems can be put. Software as a service, your office, our data center, co-hosting or hosting facilities, those types of things. So we're going to be doing all the servers, storage, security, virtualization, implementation work for all the switches, etc., that makes the modern data center go. People are not just acquiring to acquire, but to improve. So we've talked a little bit about our consulting and cloud services. Two other areas are in training, with about 600 to 800 or more classes at any one point on our training schedule. And that's going to be in all the types of technologies I just mentioned, plus probably about 2 or 3 dozen more, from Cisco to VMware, from all the Microsoft courses, a lot of security, just non-vendor specific types of courses, all available there. Present is professional AV, so all the Teams rooms, WebEx rooms, etc. for putting the large monitors, projectors, all the speaker systems, microphone systems, digital signage from design all the way through installation. And finally, we maintain all this stuff either on a reactive basis. You call us when you need help under service and support, and we can do that 7x24. Whether you have an agreement in place with us or not, you can just follow the voice prompts after hours. Or proactively, we're under managed services, where we are the IT department for dozens of organizations in this region. So that's a little bit about System Source. Let's talk about what's coming up. So we do have other upcoming webinars. So we have one that's coming up next week. That's going to be on Microsoft Azure. And obviously, folks are very familiar with servers, whether it's a traditional server on-prem or putting a server up in the cloud, say in Microsoft Azure or Amazon Web Services. But Azure also has what they call services. And those services are kind of purpose-built servers. They could be, for example, SQL Server. So as opposed to having to stand up a whole server and all those types of things in Azure, they have ones that are kind of already pre-done, which makes it quicker to be able to do it, that are for specific purposes. And there are many of those. We'll be talking about those on Tuesday. So if you have an interest in Azure, that would be a great one to consider. Also, one that's coming up that is tied directly to this one, we put it out a couple of weeks after this session, and that is going to be looking at Wi-Fi 7. Specifically, how is Cisco Meraki implementing it? What options do they have? What solutions do they have? And so while today we'll talk more in general about Wi-Fi 7, we'll be doing a kind of a deeper dive with Cisco Meraki on the 7th of February. So you may want to sign up for that. And this is a new one because this one that's coming up is only a 30-minute webinar. Most of them are webinars are an hour, but that one's only 30 minutes. So it's kind of a quick bite at lots of information there. With that, let me go ahead and turn it over to Alex.
All righty. Well, good afternoon, everyone. We're going to talk today about securing your wireless network. I want to take a quick moment, step back in history for a moment. You'll understand where I'm going here. If anybody remembers, some of you might be too young for this, but on the 22nd of February 1980, the U.S. men's hockey team defeated the Soviet Union team 4-3. 2 days later, they took the gold medal, beating the Finnish team. That was the Miracle on Ice here at Lake Placid. And that's actually where I'm sitting right now, bringing this to you live from the press booth, overlooking the rink. We're actually doing a wireless network design here at the moment. And we are eating our own dog food. So we are on the wireless network that we are testing. So hopefully everything will work out great. So today we're going to take a look at a couple of things. We're going to take a quick look at the state of wireless. Specifically going to talk a bit about Wi-Fi 6 and 7 and how we're getting more secure with these products. With that, we're going to do a little history in terms related to wireless security to make sure we're level setting everybody's concepts and understanding. And then we're going to take a look at some of the wireless security options that are available. And then how do you find those gaps in your security? So you can imagine wireless security is probably a very important part of this network, considering that this is a combination of a public arena, a conference center, and a working facility as well. So, obviously when you're mixing the public in, security becomes a very important part. And even without that, and we're going to talk about some examples of why should you even care about security? I mean, why not just, turn it on and plug it in and call it a day? Well, couple of obligatory statistics, and I'm not a big fan of statistics because all statistics can lie, but some of these things are pretty accurate. The average cost of a data breach last year, or I'm sorry, actually 23, was about $4 million, and on average about 1.7 new malware signatures are discovered every minute. That number is actually rising probably at this point based on the way some of the things we're seeing. Most of the time it's because of weak, reused, or stolen passwords. That seems to be the major issue. And we're going to talk about that in a couple of examples. At the end of the day, the question really boils down to, do you want to test your cyber insurance policy? I would not want to push my insurance company the way they are today, most of them are, to find out whether or not our coverage is really going to work or not in a given situation. Not to mention the fact that doesn't matter whether insurance covers you, bad press never goes well. So talking about some of the vulnerabilities, these are some actual cases that have happened. In this particular one, hackers got into the casino's database through a Wi-Fi enabled aquarium thermometer, something very benign, probably on an IoT network of some sort, but obviously there was a hole in the security. Other things that come to mind, printers, TVs, media players, also infected cables. It's very easy to actually make an infected cable or an infected USB device that can gain you access to a network. And then recently, there was actually a nearest neighbor hack attack in the DC metro area. Um, the hacking unit from the Russian GRU, which is their military hacking team, attacked a firm that was supporting the Ukraine. So this was in DC. They were sitting in Russia. They tried to hack into that network, but were stymied by the client's use of multi-factor authentication, which is good. However, what they were able to do was look for a physically nearby neighbor whose Wi-Fi was within range of their target network, the people they wanted to attack, and they were able to hack that network and then use it as a jump-off point to physically put them there, essentially, so that they could use that neighbor's Wi-Fi to crack the target Wi-Fi. After it was figured out and found out, eventually, they sealed everything up and they were able to close off the hole, but they were able to return and enter back in again. This time they found a device. It was a printer that was sitting on the network and it was straddling both the the internal network and the guest network. And so they were able to hack their way in through that. So these are real life things that you don't necessarily consider because you don't see the attack. They're not there. They're not physically near you. So let's talk about where we are today and how it applies to security. So the first thing let's talk a little bit about reality versus marketing. There are two organizations out there that like to confuse us. IEEE is who sets the standards. It's a committee-driven organization. It takes many, many years to adopt a set of standards. Some of my data on here, unfortunately, I forgot to update this one. Currently, 802.11be was underway. That's what we all refer to as Wi-Fi 7. Ratification was expected in December of this past year, but it actually hasn't happened yet. So they're still waiting on that. So they're not 100%. Does that mean anything's going to really change? Probably not. It's just a matter of going back and forth and arguing over, how to dot the I or how to cross a T. In many cases, it's down to that level of challenge. Then we have this other group called the Wi-Fi Alliance, and they validate that the devices meet the standards. So IEEE sets the standard, Wi-Fi Alliance then validates that your device meets the standard. So it is a certification program. You submit your devices to them and they certify them, and then you can slap the little sticker on the box and say, you're Wi-Fi 6 certified. So currently, Wi-Fi 6, 6E, and 7 are kind of the standards that we're dealing with. Wi-Fi 6 came out a couple of years ago. It's also known as 802.11ax. Wi-Fi 6E is no different. It just adds support for 6 gigahertz radios. Keep in mind, Wi-Fi 6, Wi-Fi 5, it's not the frequency, it's just the generation. And that's where things get confusing. Wi-Fi 7 is the current generation of wireless standard 802.11be, and it works in all three frequency ranges, 2.4, 5, and 6. Interestingly, and where people get a little confused, is you can have a Wi-Fi 7 device that does not have 6 gigahertz support. So you need to read the specifications very carefully. It is not a requirement. You only have to have 2.4 and 5 in order to be certified. And you may be wondering why you would have a device that doesn't have 6 gigahertz in this day and age. There are situations where 6 gigahertz really isn't going to be useful. You want the longer range of 5 and 2.4. And so there are still valid uses for it. So what happened to Wi-Fi 6 and 6E? I mean, didn't we just start talking about that a few months ago or a few years ago? And now we're talking about 7. Keep in mind that most of the vendors are still releasing brand new Wi-Fi 6 devices still. They are co-developing Wi-Fi 6 and Wi-Fi 7 because they meet different needs, which we're going to talk about here in a moment. It is perfectly fine to deploy both in an environment because they will work together. And you have to look at the other thing about, do you want to deploy Wi-Fi 7 today, considering that it is what I would refer to as bleeding edge, not leading edge technology yet. So there are still some issues with it that have to be ironed out. We did have some slow adaptation rates during the rollout of Wi-Fi 6, mostly because of supply chain issues and the cutbacks during the COVID era. Vendors are still putting out products in the space. More will be coming, especially for outdoor usage, because there are some challenges in using 6 gigahertz in an outdoor space. We do have approval for all the vendors for the AFC database, which is the automatic frequency coordination. This is absolutely required to use 6 gigahertz in an outdoor environment. So the AFC is actually built into the access points. So the access points that are going to be used outdoors with 6 gigahertz have to have certain equipment in them, which includes a GPS for identifying where it's located, as well as internal components that can indicate where it's positioned. So both altitude as well as physical, is it leaning forward 10 degrees, right 10 degrees, and so forth, because this affects where the signal can potentially be going. The 6 gig spectrum is actually licensed spectrum and has been used for many, many years for long-haul microwave links by the telecom and public safety industry. But since those links tend to be very narrow and very focused in a specific area, it's possible for us to use 6 gigahertz Wi-Fi in an outdoor environment and not interfere. However, in order to do that, we have to have this automatic frequency coordination, which will actually check to see where are we right now. So where's your device? Is there another user somewhere in your market? And if so, avoid those channels. And this is mostly for outdoor, not for indoor. So it's similar to doing a DFS check in 5 gig. So when would we start seeing the Wi-Fi 7 devices? Well, keep in mind, as I said earlier, the amendment is technically not finalized. However, that said, they are releasing and shipping devices as we speak. From Cisco, we see the 9170 X series. Meraki, same thing, the CW9170X series. And then with Aruba, it's their 700 series devices. And then many other vendors are also releasing Wi-Fi 7 devices. Some have had them out for a little longer. I will say that in general, what we have noticed is that most of them, from some of the smaller vendors who jumped on it early, tend to be plagued with problems. They're having some issues, especially it seems with the 2.4 spectrum. And that's been across the board. Now, I'm not referring to Cisco or Meraki or Aruba in this case, but I'm referring to some of the other vendors who jumped the gun on getting stuff out the door early. So why do we care about Wi-Fi 7 today? What do we need to know about it? What's important? So you need to understand it, see where it fits into your strategic plans. Much of what Wi-Fi 7 offers, you can do with Wi-Fi 6E, specifically the 6 gig support. If you're running an aging or failing system, can you wait a couple of years for the tech to get stable? Probably not. And also consider that 6 gig will not be a one-to-one swap with existing 5 gig access points. You're going to have to plan for proper placement because the coverage patterns are different. The actual radiation patterns within the AP are different. And then there's a lot of other issues. So some things to consider. Your power needs. The testing that we're doing right now, I have 4 very large, what they call stadium access points up in an arena right now. These all require 802.3 BT, which is PoE++. In order to actually do this test, we had to lug a switch up into the rafters that was capable of running BT, because their existing network was all just basically PoE+, and the switch that was up there would not provide plus. So keep that in mind. You are going to need more wattage with these devices. So the base wattage use of the AP is higher, and you're going to need switches that can support a much higher PoE budget. Keep in mind with that, most of these APs have 2.5 gig or better network ports. Some have dual ports, which will allow lag connections. Some are as high as 10 gig. In fact, the APs that we have up today have dual 10 gig ports in them. With this, you add more heat in your closet, you're going to need to consider upgrading your HVAC. And with your power draw being higher, you're going to need to consider upgrading your UPSs as well. So keep this in mind. A jump to Wi-Fi 7 really requires a comprehensive review of your network to make sure you have all the pieces in place. And then when it comes to security, Wi-Fi 6 and 7 are in general going to be more secure than Wi-Fi 5. The reason being, we can use WPA3 to do our encryption. Also, a sidebar, better handling of interference is going to help reduce issues that lead to security problems in the first place. And when we start to break into these areas, you'll understand where I'm going with this. So taking a quick look at the history and the terms, WEP, Wired Equivalent Privacy, was first released in '97. That's when wireless first hit the streets. It was a security protocol for wireless network. It used very simple encryption to protect the data. It is no longer considered secure. In fact, it's basically was thrown out the door in around 2003 and 2004. However, people held on to it for quite some time. In 2003, WPA was released. This was Wi-Fi protected access. It brought stronger encryption with a 128-bit key. It used TKIP, which is Temporal Key Integrity Protocol, which would generate a new unique network security key with every connection. In 2004, they released WPA2. That brought stronger AES encryption to replace TKIP. And that was basically what we had until 2018, 14 years later. That's using 256-bit encryption. It uses AES and SAE, which is simultaneous authentication of equals, which is improved protection over offline attack, as well as it helps prevent password guessing. It helps reduce some of the effects of war driving efforts to hack, and it gives us more protection against dictionary attacks and brute force. Rogues, we have to understand what these are. These are devices attached to your network, but they're not authorized. It could be a consumer grade access point or router that somebody just plugged into a port. It could be an extender placed by staff to get around issues. Some hints that you might have rogues on your network. You start seeing devices from brands like Netgear, Belkin, Linksys, Omada, and so forth, but you don't have any of those officially on your network. Or you start seeing a lot of duplicate IP issues. And that can often happen from overlapping DHCP ranges between the rogue device and your production device. We also have to deal with Wi-Fi interferers. These are non-enterprise Wi-Fi devices that may interfere with your RF quality. For example, the hotspots in phones, cars, appliances, the neighboring APs, public wireless access points from places like, or companies like Comcast or Cox or Spectrum. Usually you're going to find that this is the worst on the periphery of your building where it sees your neighbors. And some of this stuff can be quite a distance from you. As an example, where I am today, I was doing some of the scanning and we were picking up wireless access points from businesses that were as much as a quarter of a mile away down the street and through the other side of the building. And so that tells you a little something about how far this stuff actually transmits. Now, it's not usable at those distances, but it still creates noise and causes interference issues. We also have a large number of non-Wi-Fi interference sources. These are RF emitters that are not Wi-Fi. Some examples: microwave ovens, heavy equipment, analog devices, baby monitors, motion sensors, signal generators. A lot of audio systems are using 5 gigahertz to transmit the audio signal. In the facility I'm in today, we have a camera system that's based on, it's part of their video feeds, and it uses 2.4. So there's a lot of different stuff out there that can cause interference that's not actually a Wi-Fi device, but it is broadcasting on the same frequency ranges. And then we also have Wi-Fi direct devices. These are all over your office today. These are your printers, screencasting devices, IoT devices. They're connected to the network. Many times they have really lousy security in them, because they're kind of made, to be cheap and quick to deploy. And many of them are just neglected. They don't get firmware updates. The companies go out of business, and you're left with a device that you might be using for years, but it's got compromised firmware and you don't even know it. So we're going to dive into cybersecurity a little bit and how this applies in the wireless world. So there's a thing called the triad, or the pillars of cybersecurity. And basically, we want to ensure confidentiality. So ensuring the information is accessible only to those authorized to get it. We want to make sure that there's integrity of that the information is accurate and hasn't been tampered. And then we want to make sure that the users have access to the services and resources through availability when needed. And so this is really what everything in security boils back to. How does it work within each of these 3 pillars as we build out? And so with that, we also have 3 Wi-Fi security profiles. So the simplest one that we have is open. There's no authentication. This is your typical guest network. You can just access it. There's no encryption and traffic flows. The next one is a passphrase. This is a personal passphrase. This is a shared secret key, i.e. it's a password that is required to authenticate to the access point. And then it's used to create the encryption standards, or the encryption keys that are used to encrypt everything, which allows it to be unique. And then the other option is 802.1x, which is your enterprise, often referred to as like a radius server. So this is an authentication process usually built in so that you have individual logins to get your encryption keys. And so this is by far the most secure. So let's take a look and break them down a little bit. As we talked about open security, open Wi-Fi security, there is no encryption. There's really no impact to your security here. I mean, it doesn't help your security, is what the low impact means. It's unauthenticated encryption and management frames that are somewhat protected. It's a moderate security impact. So this is what's called enhanced open. So there's 2 different steps to it. Most of the time you're dealing with just open, but with enhanced open, you do get some level of encryption. With WPA personal, which is what most of us are using today, this is a passphrase. It's comes under WPA2, and then the password itself creates a crypto key that is unique for every session. And then taking it a step further with WPA3, the crypto key is derived from different pieces to create much more unique keys that are harder to break and hack. Using this can have a high impact to your security. So some use cases for open, guest and public access, or a captive portal. For passphrase, things like headless devices and IoT devices, guest access where you want encryption, or managed endpoints that are not in your main directory or MDM, so they're not directly available to create a login. And then your enterprise would be for your secured internal networks, endpoints that are managed, or headless devices and IoT devices that support getting a certificate. So how are these various issues risks that we talk about? So we talked about earlier, I mentioned the term rogues. Why is a rogue device a risk to your network? Well, if you have high levels of noise and interference on your network, you're going to end up driving some of your end users that are a little more savvy to finding ways around the network internally and using other options. One of the areas where we have seen this before is in office space where they're plugging in, say, a Linksys router that they brought from home so that their corner of the office gets better service. And doing security audits in companies over the years, we have found that it's not just the rank and file that do this. We often have found in executive office suites rogue access points that are up and operational. We also have to worry about IoT and printers because a lot of these devices are poorly maintained and they can become easy attack vectors that are sitting there on your network. And then just a lot of people don't want to do a password or don't want to have to remember a difficult password. And with really low password requirements, we start creating a problem with low encryption standards and things get hacked easily. So how do you check your network? So we're going to do a little simple 6-element program that can help improve your security posture. So there are 6 elements to becoming more secure. The first one, we're going to validate the primary coverage. Second one, we're going to validate the secondary coverage to make sure we have good secure roaming. Third, we're going to identify the rogues and identify the interferers that are out there. Next, SSID security configs, followed by SSID authentication, and then lastly, physical security. So these are the 6 elements. With validating primary coverage, what you need to do is execute a wireless survey that looks at your primary coverage. You want to reduce the need for rogues by ensuring that you have service available where people need it. And so you want to target generally at no worse than a neg 67. That said, there's some flexibility here depending on what your needs are and what your client devices are. People tend to take matters into their own hands when the wireless doesn't work for them. And so by having good coverage, you're reducing the risk that people will do that. What are you looking for? You're looking for appropriate thresholds that support roaming, that support proper connectivity. You want to look at the primary AP signal strength in all your various locations. And you need to contextualize this with the details about the radio itself. So understanding the power of the radio and the channel widths and how that all plays into this as well. A lot of that carries into validating the secondary coverage, which is what is also important to help with roaming. And so with roaming, we want to make sure that we have good secondary coverage for each SSID. Now, the industry standard is neg 67 for this. Now, if you think about it, if your primary was neg 67 and your secondary is neg 67, you're talking about putting a lot of APs very close together, which may not work in a given environment. So in some cases, you might push the secondary out a little bit to like, say, neg 72. The key is you're still trying to ensure that a device has another AP to move to when it needs to roam. And with that, we also need to balance the channel width across all bands. So a lot of times when we walk into an environment, we'll find currently today, if they have 6 gigahertz, they set it as wide as they could. So they're trying 320 meg channel. And then on their 5 gig, they're doing an 80 or a 160. And then on 2.4, they're doing a 20. Well, the problem is if they're not balanced, then roaming really gets fouled up because the roaming rules, now they vary by device, but what we're finding is that, especially say Apple devices, a great example, Apple looks at the channel width and will actually prefer a higher channel width, even if it's a weaker channel, over a lower channel width that's stronger. So if you have a 5 gig radio right next to me that has a great signal strength, let's say neg 60, but I'm working off of a 6 gig 320 meg channel that's at neg 80, I'm going to hang on that stupid neg 80 channel because the channel width is wider. And the assumption is I'm going to get better throughput. Remember, you're asking a computer to make a decision, and computers don't always make the best decisions. So we want to balance the channel widths where possible. So using 20 across the board or 40 across the board, not with 2.4, but with 5 and 6 gig, you want to balance them better. We also want to make sure that the number of APs seen at each location is not excessive, but it's also enough that we can roam. So typically, wherever I sit, I want to be able to reach 2 to 3 APs total, no more than that. And then we can also adjust minimum data rates and turning off some radios, which often we do in 2.4, so that we can reduce the coverage cells and prevent overextending our 2.4 coverage. And then with that, requiring 802.1K or 802.1R, which are the fast roaming standards on all of our SSIDs where possible. You also then, as part of your security analysis, you want to identify the rogues and interferers. So you want to find all these rogue APs, determine their actual purpose, get rid of them. Keep in mind, these are often consumer grade devices with low security, and they will tend to be on the periphery of your standard coverage because that's usually where people are having trouble. So think corner conference rooms, corner offices, break rooms, things like that that tend to be on the outside of the building or the outer edges. We want to find the sources of direct and indirect interference and work to mitigate them. Keep in mind, a lot of this is self-inflicted pain through channel reuse, and then also your neighboring SSIDs from other businesses and residential in your area. Make sure you're identifying the RF interference that's not related to Wi-Fi, but uses the same frequencies. So those would be your things like microwaves, sensors, audio, etc. You're going to probably need a spectrum analysis device of some sort to conduct this type of work. And then also make sure you're trying to locate any spoofed SSIDs. As an example, the other night when I was traveling, I was in a hotel room and I noticed the hotel Wi-Fi had 2 SSIDs. The second one was actually coming off of somebody else's computer or device that they were broadcasting from. So this was actually somebody in the hotel trying to get people to sign onto their wireless network for whatever reasons, which I'm sure they were nefarious to say the least. So here's an example when we do a wireless survey. So this is an actual survey done just a couple of weeks ago, actually, in an office building in the St. Louis area. Nearest other office building was approximately 600 or 700 feet away. There were probably about 10 or 15 other businesses surrounding this one, but all, like I said, 600 feet or more away. And we found a large number of rogues within the building. So all of these devices that you see in orange, these are all rogue devices that we located. And you can see the heat from some of them was actually very strong signal strength running through this one core of the building. And if you look at the list on the left-hand side here, you see all these names, Direct, 4E, HPNV, and 5J, My Cadillac. Well, that's somebody's car in the parking lot. But then a lot of these were Roku devices. So they had Roku devices in their building that they were legitimately using, but they are a source of potential security issue. And so how we figured this out as to which ones were worth worrying about, as we selected all these rogues, we went through each one and isolated the coverage. So on this map on the left-hand side, I isolated it to the one you see highlighted in blue. AP1 Delta 4F. When I click on it, I don't see any heat map. That means that while this device was detected, it's not here. It's somewhere else. And so this was probably one of the devices that was maybe one of the cars or a neighbor with a device. So we're not that worried about it. But then on this right-hand picture, I clicked on the one that it placed here in the lobby, and it lit up like a Christmas tree. And so that device is obviously physically present. And that turned out that was one of the Rokus that was in the office. So we were able to identify it, locate it, and verify, that its purpose in life. Interferers, same building. We were walking in the one corner, and our interfering screen showed that there was a lot of interference in this area, and that it was a direct channel 165 interference, so channel 165 on 5 gig. We were not really sure what this was because there wasn't anything that we could find around the area. So we did ask for permission to get up on the roof, and while we were up on the roof, it did a quick 360. And what we discovered through a pair of binoculars was approximately half a mile away was a wireless point-to-point radio pointed directly at their building, aiming at the building behind us a little ways. So there was somebody making a wireless point-to-point shot, and it was just clipping the corner of my client's building. And that was causing interference in that particular area on channel 165. Now, that might be 165 today. It could be a different channel tomorrow if they just change their channel. So that's something you have to be aware of. And then here is another example showing what we call the self-inflicted pain. And in this particular case, we found a number of things. In the upper left corner, we found a lot of microwave ovens in use. This was right next to their break room. And so that made perfect sense. And ironically, I happened to walk through that area at lunchtime, which is why it was hotter at that point. I went back later in the day, walked it again, and the heat was gone. I mean, because nobody was cooking their leftovers. Over here on the right-hand side, in the upper right, we ran into Comcast routers. There were 3 Comcast modems inside their server room providing various services, and they all had Wi-Fi enabled even though they weren't in use. And so, we just got Comcast to disable the wireless on them so that it was no longer interfering. And then this big area kind of circled in magenta, there were just scads of Bluetooth devices, sensors, test equipment. This was all a lab space in this building. And so all of their scientific test equipment out there that used various types of wireless to communicate from the device itself or the test device to a computer and so forth, just created a mess of interference. With the SSIDs, we want to make sure that we're doing good security configs. This includes segmentation using VLANs or physical segmentation of our networks. We often refer to broadcasting versus hiding an SSID. If anybody ever tells you that hiding an SSID is good security, ignore them. It is not. It doesn't prevent me from finding your SSIDs. I do not need anything very extensive. All I need is my laptop and a very simple packet sniffing device, and I can sniff out packets on your network wirelessly, so I don't even have to physically go into your building. I can sit in your parking lot with the appropriate device and scan the airwaves, find packets of wireless data, and look inside of them for the SSID names that you've hidden. Therefore, it is not secure. However, it is not uncommon to use them to help reduce clutter so that users aren't presented with 4 SSIDs and only one is a valid choice for them. That being said, I don't recommend using hidden SSIDs because it also affects roaming. Roaming will prefer a broadcast SSID over a hidden one, and that can create some issues when you're trying to roam through an area in a very complex environment like an arena or a large conference room or auditorium. You need to understand the MFP settings, so what protocols we're using, what password security. We want to make sure we're requiring WPA3 and using the transition mode where needed. to get from WPA2 to WPA3, we want to make a move to WPA3 as soon as you possibly can. So start thinking about maybe using a Radius server in your office to do, logged in authentication. And then you want to check your settings on your WPA2 SSIDs. Make sure none of them are still using TKIP. Make sure they're only using AES. And so remember WPA3 for the win. This is going to be, it's going to have support for the new stuff. It is required by Wi-Fi 6E and 7 and will be required by Wi-Fi 8 when that becomes available. We want to make sure that we have, you want to have your infrastructure integrity, which will come with that. This will bring in your management frame protection at that level. It will add integrity to the data, authenticity, and also encryption. And to make sure, with this, you're also getting your passphrase security, much, much better with your passphrases than with WPA2. And again, I can't stress enough, you really need to drive the 12-character or longer passwords today. 8-character passwords can be hacked in an incredibly short amount of time. In fact, while we've been sitting here having this conference or this conversation with each other, honestly, we could have probably cracked quite a number of 8-character passwords. It does not take that much. A couple of things to remember: management frame protection. Make sure it's enabled and in use. This will help protect from client spoofing, AP spoofing. It will help protect some denial of service attacks, also some replay attacks, and then also some on-path attacks that are out there. So basically, we want to make sure that we are enabling every option we have for security. Hackers are not stupid. They know how to break through this stuff if you don't use it. With SSID authentication, we want to check if we're using MAC address authentication. Keep in mind that is not secure. It's very easy to spoof a MAC address. I catch kids doing it all throughout the summers. It seems to be when it gets real popular because kids are sitting around at home with nothing better to do. Doesn't take a whole lot of equipment to spoof a MAC address. And so it's very easy to spoof. And then also trying to use it, it can be easily defeated by simple device rotations. And so, your iPhone rotating through MAC addresses is going to have multiple MAC addresses authenticated, and that just makes it more complicated. Make sure you're using Radius to get the most secure possible options. And lastly, there's physical security. So today, as we were placing some of our test access points in the arena, one of the things we were discussing was just physical security. One of the areas where they were looking at hanging them was about 8 feet off the floor. And the problem with that is anybody walking by could physically hit it. It was too close. I mean, you're talking a bunch of people walking around with hockey sticks above their heads. They're going to get hit. So you're going to have physical damage. But then also, too, consider physical access. So an access point placed outdoors is an attack vector. Somebody could climb up, disconnect it, pull the network cable, and plug in if they really wanted. There's a number of ways you can protect from that. One, make it harder to reach it. Put it up higher, put it inside a cage, put it in a box. Be careful what you're putting it inside. Obviously, when I say a cage, I don't mean a metal cage. Using a plastic cage of some sort. While it's not perfect, and yes, somebody can break through it, it does provide some casual protection. Concealment is another option. You can hide them. Sometimes you can place them inside of a wall and cover it with something that's plastic so that people can't see it, but at the same time, it still manages to get the signal through. You can also use external antennas and pass the antenna out through the wall, but keeping the AP inside, for example. Another simple security option: do you turn the lights on or off? I like to turn them off when they're outside, simply because why advertise it? And then also, too, why attract every confounded bird and squirrel and spider and everything else to it? So make sure also your wired ports are secure. So as an example, here in this facility, If I want to use any of the wired ports, the IT team has to enable that port. Any ports that are not actually in use are physically disabled so that nobody can just casually plug in and hack into the network. And then all access to closets and data centers obviously needs to be physically secured, badge access, whatever methodologies you use. My recommendations obviously are logged badges so that you have access logs for in and out, as well as cameras on the door so that you're catching who's in, who's out. And so, kind of in summary on the 6 elements of wireless security, remember you want to search for your primary coverage, then your secondary coverage because you want to focus on roaming. Find your interference, make sure your SSID security is tight. Make sure your authentication is as strong as can be, and make sure your physical security is in place to keep people from gaining physical access to the network. So where do you start with all of this? Well, first thing you do is you do a self-evaluation. Have you already had an incident? Was it mitigated? Was it resolved? There really is a limited amount you can do without extensive training or tools. You may have that in-house, and that's great. If not, you may have to look for other options. But things you can do, you can check all your passwords. Make sure they're complicated, 12 characters or more, rotated periodically, and not posted anywhere. I was amazed the other week. I actually did find an admin password on a keyboard on a post-it note, and it wasn't even under the keyboard. It was actually on top, and it was not in a secure area. Make sure you have a password change policy in place, so how often you change the passwords. And then to take a deeper dive, you're going to need to identify who the resource or partner is that's going to assist. It could either be in-house or outsourced. The skill set that they're going to need, this type of person's going to need to have a wireless understanding at what I call the CWNA. This is the Certified Wireless Network Administrator and the Certified Wireless Security Professional level. I'm not saying they have to have those certifications, but they need to have the understanding at that same basic level. They should have a network understanding at the CCNP level, so that was the Cisco certification levels. Good solid understanding of IP, routing, configurations, how switches operate, VLANing, things like that. They should be familiar with the technical specs of the gear that's being used. And then the tools, they're going to need an RF signal meter of some sort to gather signal information. They're going to need a spectrum analyzer to gather and view the data. And they're going to need some sort of application to gather that data and put it all together in a format that's actually usable. Some examples of survey tools that are out there. For example, there's a device kind of like a multimeter, NetAlley's AirCheck G3 Pros. These run between $3,500 and $4,500. They're very limited as to what they do. They're really for just troubleshooting and reading what's there. They're not meant for designing a network. Moving up into the higher level tools, our go-to is Ekahau AI Pro and the Ekahau Sidekicks. This package runs about $8,500. They have a solid development effort behind it. It's a very flexible device. And then an up-and-comer is Hamina with the Osseum Nomad devices. These run around $4,000, give or take. This is a newcomer. A lot of the development team that are building these used to work for Ekahau, and so they've gone out and done a kind of like the best of all the tools and put it together to make a new tool. The problem right now is you need to add a spectrum analyzer to that because it does not have that built in. On the low end, for simple spot checking, you can use something like Wi-Fi Explorer 3 on a laptop. Runs you about $150 on a Mac or Windows device. It's just a very basic signal strength. And then there's also a product called NetSpot, similar price point, about $200. We'll give you some other information, but a heat mapping. Again, not for designing, just for very simple spot checking. All of these types of things work with the network card on the device. So whatever your limitations of your device are going to be the limitations of what you can test. Other option you have is to engage a professional site survey. This is a wireless expert with solid education on wireless trained in networking concepts, uses the professional grade tools, active in the tech forums and industry discussions, and they follow industry best practices. In addition to obviously other practices like your own and theirs and such, but they really follow those industry practices, which are tried and true. During a wireless security audit, they're going to spend a little bit more time on the security aspect. So when we do a security level audit, not only do we do the wireless audit, but we focus on that security aspect as well. So we're going to check all of these different things that we talked about. We're going to be looking at that secondary coverage. We're going to be looking for those interference devices. We're going to be looking at the controller and how things are set up for authentication and for passwording and such. And we're going to spend a lot more time trying to find these rogue devices and really sort out who they are and what they are. And so with that, remember, security is important. Incidents of hacking are on the rise. We see it every day. We know there are active hackers out there constantly trying to break through things. Security requires more than one layer. You need different layers in order to protect yourself at different levels. Make sure you're using strong encryption, lengthy passwords, segment your traffic, good firewalls, good VLANing. Keep that firmware up to date. That is incredibly important. And really consider moving to Wi-Fi 6 and 7. Remember, a solid performing wireless network is going to be less prone to hacking. And so that's an incredible, important thing to take with you on this. And with that, Chris, I will turn it over to you for questions. We'll go from there.
Thank you very much, Alex. So we don't have any questions at this point, but if those have a question, you're welcome to put it in here. I'll just make a couple comments. So when you get the evaluation form, there are some options for things that you can pick, or you can obviously write in other things that you might find helpful, and we'll be happy to try to get for you. But some of the things are going to be like the wireless security audits and scans, and the various wireless designs and audit kinds of services. So if those are the kinds of things that you need, we can obviously help you with those things as well. So I don't see any questions at this point. So I want to say thank you to each of you. We appreciate your time very much. Hopefully the information was good. Thank you to Alex. And we look forward to seeing you in another webinar soon. I hope you have a wonderful afternoon. Thanks, everybody.